All right, hi folks, this is Larry Maslino. I'm recording a video here for Objective 15 in Alex. And if you notice here, there's about 10 topics, and it really has to do with solving what's called a quadratic equation. So let me give you some background on solving a quadratic equation, because it turns out there's several different methods we could use. All right, well, first, what does it mean to say a quadratic equation? Well, remember, quadratic equation means there's an x squared or a y squared. So when you see a quadratic equation, you'll know it because it'll have an x squared or a y squared in the equation. Now, there's several ways to solve these equations. One method is called the square root property. And this method will be used when we have something like x squared equals a number. So notice in this quadratic equation, there's no x, there's only an x squared. So when you see that, an x squared only, that's a good time to use the square root property. There's going to be another method called completing the square. And for that, we're going to try to get an equation to look something like, let's say, x plus 5 squared equals 10, let's say. Okay? And again, notice this is like a squared quantity equals number. So this is kind of like the square root property. The only challenge is going to be to get the left side in this kind of format, and we'll talk about that in a few minutes. Another method that you probably remember is factoring, where you factor the one side of the equation. And then the last method is the quadratic equation. Quadratic formula, sorry, quadratic formula. Okay? So, it turns out that this method, quadratic formula, can be used on any equation. And also completing the square can be used for any equation, any quadratic equation. All right, so let's do some examples, and we'll use these different methods, and we'll try to identify when is it best to use a certain method. All right, let's look at this example here they're giving me. Y squared equals 64. Well, I'm noticing this is just a y squared. There's no y in this equation. Well, when that happens, it's easiest to use the square root property. What the square root property says is take the square root of both sides. So here's what we have, y squared equals 64. Well, I'm going to take the square root of both sides here. The reason I do that is on this left side, square root and squaring are inverses. They're opposites of each other, so they cancel out. So if I take the square root of y squared, it gets me just back to y. Now, the only other thing I got to be careful about is when I take the square root of the right-hand side here, I've got to put a plus or minus in front of this equation to be sure that I am going to end up with two possible solutions. Well, the square root of 64 is 8, so I end up here with y equals plus or minus 8. Really what that plus or minus sign is telling me is there's two separate solutions. One solution is plus 8, and the other solution is y equals negative 8. Now, if I had forgotten to put this plus or minus sign here, I would have missed out on this one solution, y equal negative 8. So in this example, there's two solutions or two answers, y equals 8 and y equals negative 8. And you can double check this. If I take 8 squared, I do get 64. But what if I take negative 8 squared? Well, negative 8 times negative 8 is still 64. So those are both valid answers. So one important thing to remember is anytime you take the square root of both sides, like in this example, you have to remember to put a plus or minus sign in front of this square root symbol like that. Okay, let's do another example, maybe similar to this. Let's take a look here. All right, now this one is asking us to solve an equation, and it says x squared equals negative 12. All right, now before I do this, let me think about this for a second. Well, I'm going to try to square a number and get the answer negative 12. Well, if I square a number, that answer always has to be positive. You know, if we did 8 squared, the answer was 64. If we did negative 8 squared, we still got 64. There's no way to square a number and get a negative answer. You could probably see that too, because if I take the square root of both sides, I end up with the square root of a negative number, which I know is not a real number answer. So this problem is no solution. You can never have x squared equal a negative number. There's never going to be an answer for this, because I can never take a number times itself and get a result that's negative. Okay. Let me come here to completing the square. All right, now we're going to do an example of solving an equation by completing the square. But first, they're going to ask us to get a little practice here on the mechanism of doing what's called completing a square. So let me give you some background on what we're trying to do here. We're going to try to solve a quadratic equation. But I want to be able to get this to look like, let's say, x plus 5 squared equals 10. Well, if I was to expand out this side, this would be x plus 5 times x plus 5. And if I do a FOIL multiplication on this, this will be x squared plus 5x plus 5x plus 25, which is x squared plus 10x plus 25. So what I want to do is get this side, this left side here, to look like a quantity times itself, because that's a squared quantity. But sometimes the expression you get here is not representing a squared quantity. Complete the square means you're going to rewrite it so it is a squared quantity. Now, one thing you might notice here is this number 25. The way that 25 came about is we took 5 and squared it. Remember, we took this 5 times 5 and squared it. That's how we got the 25. But 5 is 1/2 of this number 10. So to complete the square like this, there's 2 steps. One is take whatever number is in front of x, we call that the coefficient. Take the coefficient of x and divide it in half, divide by 2. Then take that result from step 1 and square it. For example, in our example here, the coefficient of x was 10. So I would take 10 and divide by 2, that would get me 5. Then I would take 5 and square it, that would get me 25. So let's go to this example. They're asking us what number would go in this blue box in order to complete the square. All right, well, let me follow the steps. It says take the coefficient of w in this example. Well, the coefficient of w is -6. Divide it by 2. Well, that's -3. Square that result. Well, -3 squared is 9. So the number they want me to put in this box is a 9. Because by putting a 9 in this box, I would end up with this kind of a squared quantity. W squared minus 6w plus 9 is really the same as w minus 3 squared. So in this example, they really just asked us to come up with this number 9 that allows us to complete the square. That means you're trying to get the expression to be a quantity squared. In this case, it was the parenthesis w minus 3 squared. Okay, so these are the steps to complete the square. All right, well, let's look at an example of actually using this method to solve an equation. So let me go to the next topic. Notice here it says solving a quadratic equation by completing the square. All right, let's take a look at this one. All right, so what they're giving us here is this equation, x squared minus 4x minus 3 equals 0. All right, well, I want to complete the square. What that means is I want to get this left side to look like a quantity squared. So here's what I'm going to do. I think it'll be easier to bring up the explanation this way we can follow it step by step. Okay. All right, here's what we're going to do. Remember, our goal, as I mentioned just a minute ago, is to get the equation to look something like this or something like this. Notice we have a squared quantity on the left-hand side. All right, so what we're going to do to get started on this is we're going to get the left side of the equation to only be the x squared and x part. Let me scroll up here a little bit. And let me write this equation down. So here's what we got. All right, the first thing I'm going to do is try to isolate this part of the equation all by itself. So to do that, I'm going to get rid of the subtraction of 3. I'm going to add 3 to both sides. So we have x squared minus 4x equals 3. My goal is to get this left side to be a squared quantity. So we're going to take this left side and complete the square, just like the example we did a second ago. All right, you might remember step 1 is take the coefficient of x. In this case, it's -4. Divide that by 2. That's -2. And then square that result. -2 squared is 4. So that means I'm going to add 4 to both sides of this equation in order to complete the square. All right, well, if I do that, I'm going to end up with x squared minus 4x plus 4. And on the right side, I have 7. Well, the whole point of doing this is to make this left side be a squared quantity. Let me factor the left side. I can see that better if I factor. Well, if I factor this, you might notice it's going to be x minus 2 times x minus 2. But I can write that as x minus 2 squared. All right, now I have a squared quantity equal to a number. Notice we're matching this setup now. All right, well, the last step now is take the square root of both sides. So I'm going to take the square root of this side and the square root of that side. Because remember, I want to get rid of the squaring. And to get rid of squaring, take the square root. All right, but remember, I got to put a plus or minus in front here. All right, so this square root cancels out with that squaring. So I have x minus 2 equals plus or minus the square root of 7. Then make this a little easier. I know the plus or minus sign means use the plus sign one time and then use the minus sign. So I'm going to break this up into 2 equations now to make it a little easier to work with. I'm going to write this as x minus 2 equals plus the square root of 7. And the other equation is x minus 2 equals negative square root of 7. Last step, for each of these equations, I want to get x by itself. So I'm going to add 2 to both sides here. That's going to get me x equals 2 plus the square root of 7. And I'm going to add 2 to both sides here. That gets me x equals 2 minus the square root of 7. And in this problem, they want you to leave the answer in terms of square roots like this. They don't want you to work this out on a calculator and come up with a decimal answer. And I know that because there's no rounding instructions. So if there's no rounding instructions, Alex wants you to leave the answer like this in a square root form. We call this an exact answer. All right, so let's go to the example here. Remember, we ended up with this equation, x minus 2 squared equals 7. So that's what they want me to enter here in this box. So I would put a 2 in this box here and a 7 over on this side. And then they want me to enter the solutions, and they say separate multiple answers with commas. So I would enter this answer. So my answer would be 2 plus square root of 7, comma, 2 minus square root of 7. By the way, we're going to talk about the quadratic formula in just a minute. And if I had used the quadratic formula on this example, I would end up with the exact same answer. So, you know, you can use complete the square or use quadratic formula. Either method gets you the same answer. Most times students prefer the quadratic formula. It's a little more direct. completing the square is a little challenging, but once you see the setup, it's not as bad as you might initially think. All right, let's look at a couple more examples. In fact, why don't we go to the quadratic formula? We'll do a couple of examples. All right, so this one says solve the quadratic formula. It says use the quadratic formula to solve for x. All right, well, first thing we need to know is what is the quadratic formula? Well, if you go to the reference packet, you'll be able to look up the quadratic formula. It says x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Remember, you don't have to memorize this formula. You can look it up on the reference packet. Well, here's what we're going to do for this example. The first thing you do is compare this equation to ax squared plus bx plus c equals 0. Because what we need to do is the first step is we need to identify what is a, what is b, and what is c in our example. I do that by just comparing. A is whatever number is in front of x squared. Well, in our example, it's a 2. B is whatever number is in front of x. In our example, that's 6. And c is whatever constant is over here on the right side. In our example, that's negative 1. Now that I know a, b, and c, I plug in these values into the quadratic formula, and then I'm just going to work this out numerically. All right, so let's work it out. So first thing is, in place of b, I'm going to drop in a 6. So this is going to be negative 6 plus or minus. Let's go under the square root. It says b squared. Well, that's going to be 6 squared minus 4 times a times c. Our a number is 2. Our c number is negative 1. All over 2a. That's 2 times 2. All right, let's keep going. Let me go underneath the square root. Now, when I go underneath the square root, I really have to follow order of operations. So I want to work out the square, the exponent 2 first. 6 squared is 36. Then I work out multiplications next. 4 times 2 is 8. 8 times negative 1 is negative 8. So it's a subtract a negative 8. All over 2 times 2, of course, that's 4. All right, well, let me go underneath the square root again, because 36 subtract a negative 8 is really the same as 36 plus 8. So that's going to be the square root of 44. All over 4. All right, well, remember, I'm not going to work out the square root of 44 in my calculator because this says give exact answers. And again, because Alex is not giving me any rounding instructions, I need to just leave the answer as a square root. But I do want to simplify my answer if possible. And I'm noticing that the square root of 44, I can really think of that as 4 times 11. Right? 44 is the same as 4 times 11. Well, that means I can break that up to be 2 separate square roots. So I'm going to think of this as the square root of 4, square root of 11. But I know the square root of 4 is 2, so I'm going to write this as plus or minus 2 times the square root of 11 over 4. All right, well, there's one more simplifying step I can take because I can factor out a 2 from this numerator. So I'm going to do that. I'm going to pull a 2 out in front. That's going to leave me negative 3 plus or minus the square root of 11. And on the bottom, I have a 4. But I can think of a 4 as 2 times 2 if I want. The reason I'm doing that is now I could see that this 2 on top cancels out with one of the 2's on the bottom. So finally, I'm left with x equals negative 3 plus or minus the square root of 11 over 2. But Alex is going to want me to enter these as 2 separate answers. So I'm going to break this up into 2 answers now. The first answer is going to be when I use the plus sign. The second answer is when I use the minus sign. So these are the 2 solutions we came up with using a quadratic formula. Okay, so it's a little messy with the numeric calculations, but The basic idea is first identify A, B, and C. You do that by comparing the equation you're given with this template, ax squared plus bx plus c equals 0. Once you know the values of A, B, C, you plug them into this quadratic formula, and then just work out the numeric values. Got to be careful when you're working underneath the square root here. Be sure to follow order of operation. All right. There's another example here. I'm not going to do this one because it's basically the same. The only difference is on this one, you are going to work out the square roots on a calculator, because I'm noticing this one says round your answer to the nearest hundredth. So let me just set this one up for you. Now, the first step when solving quadratic equations is we need to get the equation set equal to 0. So I'm going to add 1 to both sides of this equation, because if I do that, I'm going to end up with a 0 on the right side. All right, now I'm going to compare this equation to ax squared plus bx plus c, so I can identify A, B, and C. In our example, A matches up to 2, B matches up to 7, and C matches up to 1. All right, let's go. We might as well work this out. Let's go plug into the quadratic formula, which looks like this. So I'm just going to replace each of these letters. Our B number is 7. A is 2. C is 1. And on the bottom, 2a is 2 times 2. All right, let me keep going. Underneath the square root, 7 squared is 49, minus 4 times 2 is 8. 8 times 1 is still 8. All over 4. All right, well, this is going to be negative 7 plus or minus the square root of 41 over 4. I can work this out on the ALEKS calculator. Just remember that when you do this, you have to break this up into 2 separate solutions. The first solution is going to be when I use the plus sign on the top of the fraction. And the second solution is when I use the minus sign on the top of the fraction. Okay? And then you could go work these out on your calculator. Let me work these out so you can try this yourself. When I work these out, I'm ending up with this first answer. It's telling me to round to the nearest hundredth. That means 2 decimal places. So for this answer, I'm getting negative 0.15. And let me do the second solution. When I do the second solution, I'm getting negative 3.35. So these would be the 2 answers to enter into ALEKS. Okay, so on this problem, you'll have the ALEKS calculator pop up. Okay, I'm going to go to explanation. We'll double check our answers here. So you can see the ALEKS answers, x equal negative 0.15 and negative 3.35. All right, so this is using the quadratic formula. Again, please remember you have this formula available to you in the reference packet, so please use that in the reference packet. All right, let me, how about if we do one here that's a little different, because I'm noticing this one says find the complex solutions. So here's what can happen. When you take the square root of a negative number, you will end up with an imaginary number. If you remember back in Objective 14, we worked with I. Remember, I was the square root of negative 1. So what we're going to do now is find these solutions, and this will lead us to taking the square root of negative 1. And when we do that, we're going to end up using I as part of our answer. All right, so I'm going to go to the explanation to get this to set up. All right, let's do it. So here it is. Here's the famous quadratic formula. Let me compare our example here to ax squared plus bx plus c. I'm noticing that A is 3, B is -4, and C matches up to 5. All right, so I'm plugging all of these numbers into the quadratic formula. Here it is. Let me go underneath the square root for a second. Let's take a look at the square root. Well, I'm going to work out the exponent first. -4 squared here is +16. Then I got to do this multiplication. 4 times 3 is 12. 12 times 5 is 60. So this is going to be square root of 16 minus 60. When I work that out, that's a -44. So notice this is going to be the square root of a negative number. But here's what I'm going to do. I'm going to break this up to be the square root of 4 times 11 times -1. Remember, you want to break out -1 separately, because now I can break this up into separate square roots. It's going to be square root of 4, square root of 11, square root of -1. The square root of 4 is 2. The square root of -1, you probably remember from last objective, I is equal to the square root of -1. So this is going to be I, and I'm just going to bring down the square root of 11 with me. I can't do anything else to simplify the square root of 11. Okay, so let me scroll down here, show you the rest of this worked out. So notice here, let me clear this. So notice here on the top, they ended up with 4 plus or minus 2 times the square root of 11i all over 6. What Alex does here is it breaks it up into 2 separate fractions. So when we have 4 plus or minus 2 square root of 11i over 6, you're allowed to break this up into 2 separate fractions. You take this part of the numerator, the 4, put it over the denominator 6, and then we could take this second part and put that over the denominator as well. One last step is now I can simplify these fractions, because 4 over 6 can be simplified to 2 over 3, and this 2 over 6 can be simplified to just 1 over 3. So here is the final answer. Okay. And of course, remember, this really breaks up into 2 separate answers. One time when you use the plus sign, one time when you use the minus sign. So you can see down here is what you'll end up with is the final answer. All right, so again, this was using the quadratic formula again in the same way. The only thing different about this example is the square root ended up being a negative number. And when the square root is a negative number, you're going to factor out the square root of -1 separately, and remember I is equal to the square root of -1. All right. Let me go to maybe one more topic here. It talks about the discriminant. So when you're working with a quadratic equation like this, there's a certain calculation that you could do that helps out. And the discriminant is just calculating a quantity. Here it is, discriminant. I should be able to spell at this point, but I guess I can't spell. Discriminant. Okay, it's just the quantity b squared minus 4ac. So again, I'm going to go back to this equation and just compare the equation they gave me to ax squared plus bx plus c. When I do that, I'm noticing a matches up to -3, b matches up to 7, and c matches up to -3. So all I'm going to do is plug these numbers into b squared minus 4ac. You might remember this is the quantity that's under the square root in the quadratic formula. And the reason this is useful is if this result turns out to be negative, well, then you'd be taking the square root of a negative number. Well, that would tell you you're going to end up with complex number solutions. So let's work this out, because that's what they're asking us here. They're asking us to work out the results. So let me just plug in. B is 7, so this is going to be 7 squared. A is -3, C is -3. All right, well, I'm going to use order of operations. I'm going to do the exponent first. That's 49. Next, I'm going to do this multiplication. All right, 4 times -3, that's -12. And then -12 times -3 is +36. So I'm ending up here with 49 minus 36. That works out to be the number 13. Notice this is a positive number, not a negative number. If it was a negative number, that means we would be taking the square root of a negative number in the quadratic formula, which would lead us to complex solutions. Well, let me go to the explanation just to show you some a summary here. Let me erase something to make it a little easier for us to read this here. All right, so we just worked out the discriminant, right? And that's b squared minus 4ac. So we just worked this out. We got the number 13 as our answer. Now I come here. It says if that answer is greater than 0, that means there's 2 real solutions. So our number is greater than 0. So our conclusion is there's going to be 2 real solutions. So when they ask us, what's the number of real solutions? The answer is 2 real solutions. What if I worked out this discriminant and I got the answer 0? Well, here it says, if b squared minus 4ac turns out to be 0, your conclusion is there's 1 real solution. And what if b squared minus 4ac is less than 0? That means negative. Well, that means there's no real solutions because they're going to be complex solutions. Okay, so for this problem, all you have to do is work out the quantity b squared minus 4ac, and then come to this little summary here and decide whether your answer was greater than 0, equal to 0, or less than 0. That'll tell you the conclusion to use for this example. All right, folks, hope this is helpful as you're working in Objective 15. Please let me know if there's any questions.